Hello and welcome to today's Knowledge Break webcast. My name is Des Rathall and I am Director of Alumni Relations for the College of Earth, Ocean, and Atmospheric Sciences, CEOS for short, here at Oregon State University. Thank you for spending your lunch hour with us as we embark on a tour of the ocean's floor with leaders from OSU's amazing Marine and Geology repository. Before I introduce our speakers, I'd like to take this opportunity to say a big thank you to our generous donor community. On April 28th, Oregon State celebrated Damn Proud Day, a 24-hour event dedicated to giving and connecting to support OSU's education, research, and service mission. The Oregon State community gave more than $1.1 million. And we're proud to say our college, CEOS, received the most gifts of any college. CEOS donors make it possible for students to have amazing learning experiences from geology field camp to conducting research at sea. So thank you. Learn more about supporting CEOS by visiting osufoundation.org. Today's talk is a collaboration between the OSU Foundation, the OSU Alumni Association, and CEOS, and of course, you. You're invited to share your questions at any time during today's presentation by using the Q&A button at the bottom of your screen. Our speakers will answer as many questions as time allows. I'm excited to introduce today's speakers, Val Stanley and Dr. Joseph Stoner. Val is curator of the repository's Antarctic core collection, the world's largest collection of geological samples from the Southern Ocean. She led the transfer of this collection to Corvallis from the Antarctic Research Facility at Florida State University. Her research interests look at the curation and preservation of physical samples, as well as the digitization of that data. As she puts it, she's a mud librarian. Dr. Joseph Stoner is a CEOS professor and the co-director of the Marine and Geology Repository, a role he's held since 2010. He's worked around the world using sediments to reconstruct past variations of Earth's magnetic field and explore what those variations can teach us. During his career, he has spent more than a year at sea on national and international research expeditions. So let's start our tour. Welcome, Val and Joe.
Well, hello, everybody. Thanks for coming today. And I'd like to welcome you to the Oregon State University's Marine and Geology Repository. We are located 2 miles southwest of main campus on Research Way, just down the block from OSU Foundation in Corvallis. Joe and I are going to talk to you all today about what we do at the repository with our large collection of ocean sediment samples, mud and sand collected from the bottom of the seafloor. A repository is sort of a cross between a library and a museum. At our repository, we organize a collection of scientific samples for active and future research. Scientists visit the facility to examine sediment cores and analyze them using our instruments to learn more about their physical properties through time. The cores come to us as 150 centimeter long pipes like you see here, and we split them in half with our saw to create 2 halves. One for archive purposes and another for researchers to collect smaller subsamples for more detailed analyses. We house samples from all around the world, including over 13,900 coring sites. And if you lined up all those cores end to end, you would have over 24 miles of sediment. Researchers request small volumes of material from these cores, and curators collect and distribute these subsamples. Annually, we give out about 8,000 subsamples to support many different research projects. The repository started up with very humble beginnings, with several OSU professors stashing their cores in a shared walk-in refrigerator of a Chinese restaurant on 9th Street in Corvallis. In 1975, the National Science Foundation funded OSU to establish a designated space as a core repository on campus, including funding for curatorial staff. Another core repository existed at Florida State University, housing the largest collection of sediment cores from the ocean floor around Antarctica. In 2015, FSU decided that they no longer wanted to support that facility, and NSF began to look for a new home for it. Oregon State applied for this task and was chosen to take on this additional collection in 2016. The Antarctic core collection moved to Corvallis from Tallahassee over 5 weeks in the summer of 2018. We packed up and inventoried the collection into 14 52-foot refrigerated trucks. Then the work began to move everything into the new facility on Research Way, including the move from the old repository on campus. Our new cold room that you see here includes 10,900 square feet of refrigerated space, using 20-foot high racks and specially designed cages with enough extra space to hold new samples for the next 50 years. These cages are holding kind of funny shaped tubes that you see, and these are actually specially designed for curating halves of sediment cores. We call them D-tubes because they are shaped like a sideways letter D. Most of these cores are collected using a piston corer. And to learn a little bit more about that device and that process, we've got OSU Assistant Professor Mo Wazak explaining how exactly we collect them.
Great.
As you might guess from the title, a piston coring system centers around the use of a piston in the top of the core barrel, and that piston serves the function of providing a vacuum when the core goes into the sediment column that prevents the sediments from being deformed and squished as the barrel goes into the sediment. The piston coring system is lowered from the ship, and it has two parts to it. The way we do it at OSU involves a trigger weight or a trigger core, and that trigger core is attached to a line several meters in length, and then that whole mechanism is at the top of what we call the core head, the weight stand of the core. That weight stand has thousands of pounds of lead weight in it, and then that lead weight is on the top of a length of steel pipe that, depending on the environment, will be rigged to be between 20 and 50 feet long on average. And when you hit the sediment bottom, that trigger weight hits first. And when that trigger weight hits first, it releases the tension on something called a trigger arm, and that releases that free scope of line. And then the piston core, which has been held by that line, free falls into the bottom at really incredible speeds. And it again, rams that steel pipe. It can ram it through glacial clay, tens of meters.
All right, and so now that we've shown you our facility, we would like to tell you a little bit more about some of our cores and the scientific stories that they tell us. So first off, we'll fly to Greenland, where Joe will tell you more about Petermann Glacier.
Here we are at Petermann Fjord and Glacier in northwest Greenland. This glacier and the ice tongue that extends from it became of special interest in 2010 when the 97 square mile chunk broke off and floated away. In 2015, an OSU team traveled to Greenland as a member of an international group of scientists studying the glacier's history. We set sail on Swedish icebreaker Odin to collect sediment cores from the fjord to reconstruct the history of this part of the Greenland ice sheet. Such histories put present behavior in perspective while allowing us to learn about times when the atmosphere and ocean around Greenland was different from today. We took several different types of cores, including piston cores and multi-cores from Odin, as well as Uvatec cores from beneath the ice tongue. Here you see the OSU coring group collaborating with the Swedish coring group. Many of these cores were split at sea using a different device than we have at the repository. We do this to understand what we're collecting and describe the cores while at sea, because once you split, the cores begin to change. For example, they change color when exposed to air. We're now going to show you a video of a coring device called a multi-core, which is much lighter in weight than a piston core and is used to collect sediment from the very surface of the seafloor, also known as the sediment water interface. You will see the multi-core going down 960 meters, 3,150 feet deep to the seafloor within the fjord. The chirping sound that you hear in the background is a type of sonar used to get water depth and a profile of the ocean bottom before taking a core. Here is an image of one of the cores we took. On top is a high-resolution photographic image taken here at the repository of a core collected from beneath the ice tongue. On the bottom is a CT scan of the same core taken over at OSU Veterinary School of Medicine. CT scans are an innovative way to learn more about the structure of a core, capturing changes in density that can even be explored in 3D. Shown here are light, high density, and dark, low density bands. In this figure, we see a series of cores we took in a line along the fjord. By looking at all of these cores together and dating them, we can learn how the system responds and has responded in the past. We have learned that this ice tongue that is now disintegrating is several thousand years old, and from these cores, we were able to reconstruct how the system retreated many thousand years ago, regrew, and is now retreating again. Now, these Greenland cores collected in 2015 are housed at the repository. We had certain research objectives going into this project, but there are many more questions that remain to be answered about the Petermann Fjord Glacier and Greenland ice sheet. These cores can continue to be analyzed by researchers without having the cost and effort of having to go all the way to Greenland again. Now Val will talk to us about another core, this time from the bottom of the Earth.
Thanks, Joe. So here we are, walking down one of the aisles of the Antarctic core collection. As you can see here, the majority of the collections of the repository are piston cores stored in these D-tubes that we've talked about. We also house cores collected using a different kind of device called a drill core, so diamond drilling, stored in standard cardboard boxes. All these boxes stacked up in front of us right now are from the famous core and 1-1B. So in the Antarctic summer of 2006-2007, the Antarctic Geological Drilling Program, or the famous ANDRIL project, successfully cored a 3/4 of a mile long record of climate and glacial marine history spanning the last 13 million years. This is the longest core in all of the MGR collections. This core was recovered from underneath the northwestern corner of the Ross Ice Shelf and shows that the ice shelf melted back about 58 times. The coring platform that you see here under a white tent was situated on top of 270 feet of ice, which was floating on top of 2,740 feet of water. These particular sediments in front of you now represent a transition in climate conditions 2.5 million years ago, 600 feet below the sediment water interface. Temperatures were so warm that there were open waters in the Ross Sea, shown in these smoother sediments full of sun-loving organisms. But we know that ice was nearby because of the rare pebbles throughout the section, like that black chunk right there, dropping from icebergs floating by. Then conditions changed and became much colder so that an ice shelf filled the Ross Sea. And we know that the Ross Sea was filling up with ice because of these chaotic looking sediments full of pebbles and gravels bulldozed by that ice into place. There's a huge variety of rock types here, indicating that they came from many different source locations that the ice traveled over. So these two sediment types that I've shown you here are a common pairing in and 1-1B that repeats over 58 times within the 3/4 of a mile long core. The repeated pattern explains how climate impacted the Ross Ice Shelf over the past 13 million years. And now I'll pass the mic off to Joe, and he will tell you more about a local coring site.
So now we're traveling closer to home to the northern Oregon coast, where we sampled off the mouth of the Columbia River to study the regional climate history of the last 20,000 years or so, which is approximately when the Earth experienced the last ice age. In this part of the video, you will see many undergraduate students doing the work. Our college supports a yearly undergraduate field course on the research vessel Oceanus, which is run by OSU and docked in Newport. The students get to experience all different aspects of going out to sea and using a variety of sampling instruments. You can see the students labeling the cores and cutting them into standard 5-foot pieces. so that it can be properly curated back at the repository. Here are the students assembling a multi-core containing 8 small core tubes that can collect up to 25-inch long samples. It's quite a unique opportunity for the students to experience oceanographic research firsthand. Now we're seeing video of a multi-core going down to 761 meters, or approximately half a mile, down to the bottom of the Oregon seafloor. Notice how different the environment here is compared to the multi-core video taken from the Petermann Fjord. Let's pull out and look at one of the cores from this cruise. This core represents the last 20,000 years off the Oregon coast, at which time the massive Cordilleran ice sheet extended into Washington, Idaho, and Montana. This ice sheet created enormous ice dam lakes. Now let's look at some pictures of cores from off the Oregon margin. They're beginning to show us how these ice sheets retreated. Notice the light colored bands. These bands contain minerals found in rocks from eastern Washington. These sediments were transported by megafloods caused by the early retreat of the Cordilleran ice sheet around 19,000 years ago. Now notice on the right of this section of the core, you see the massive deposit which may have corresponded to the outburst of Lake Bonneville, the large precursor of the Great Salt Lake in Utah around 18,000 years ago. The narrow dark bands in this section above indicate a rapid accumulation of terrestrial organic matter carried by floods. These are all part of what's collectively known as Missoula floods and illustrate the complex history of these events so well preserved in the marine record. The source of these floods was the repeated failure of ice dam glacial Lake Missoula and possibly other glacial lakes as the Cordilleran ice sheet began its ultimate retreat to the north. And now back to Val.
So here we are heading back to the repository. This building was originally constructed as the NIPRO building, where parts were fabricated for inkjet printers. OSU purchased the building for general storage in 2008, and now it has been renovated and serves as a world-class research facility. And now you will hear more about the value of this facility to the scientific community from Joe, Mo, and Chief Curator Maisie Chesaby.
So sediments are in essence just mud until you actually add data to them. So when you put data on them, you can transform them from mud to understanding.
Every core, we run the multi-sensor core logger on it, so that gives us density data, it gives us porosity data, it gives us magnetic susceptibility data, photograph all the cores, and then we do sedimentological descriptions of the cores. And if we had the funding, we would CT scan all of them as well. Those are the standards, but there's other things that you can do. So you can also run elemental analysis on them before, as I told you. And we also can do photospectrophotometry, which actually is a machine that is telling you what the differences in the colors are rather than a human being doing it in a core description.
We've taken our collection of primary cores from the Pacific and added to it a whole collection of cores from the Southern Ocean that were collected from the 1950s essentially onward.
Both collections, the Antarctic collection and the original MG&G collection, comprise of 22 miles of core.
And we have 10,000 samples of these dredge collections from all over the ocean floor.
We have 1,600 sediment trap samples, miles of drill core, but we also have NOAA rock grab samples from ROVs, 196. And then we QR coded all of the D-tubes. So there's a QR code that is for the metadata, so just basic data like latitude, longitude, water depth, when the core was collected. And then there's a second QR code which actually links to URLs that you can click on, and then that gives you real data. So that'll give you the XRF data, it'll give you the multi-sensor core log data, it'll give you a CT scan. So we were able to do that with the entire OSU collection.
This is the largest archive of its kind on the west coast of North America. It's one of only a few such facilities in the world. And the scientific and cultural value of this collection is immeasurable. This facility allows researchers to come from all over the country who are studying all of those different processes that we discussed and look at archives that might have been collected in the 1940s or the 1950s. They can look at cores that were collected in Antarctica or cores that were collected in the Arctic Ocean. It allows researchers from smaller schools who have really good research ideas but don't have access to ships to take advantage of these materials and ask innovative research questions that help us better understand our world.
Thanks for joining us today for our tour of the repository and to view some of our cores. And now I'll turn it back to Des for the question and answer session.
Thanks, Mel and Joe. That was fascinating. I think the big last event I attended in early 2000 was the grand opening of the new facility that you have. I venture to guess that some of our guests today were there as well. I remember what struck me the most was standing in the floor to ceiling rows and rows of cores, like in the images behind you, and feeling almost a sense of awe, imagining the places they came from. And your virtual tour today brought those incredible places right into our living rooms. So thank you for that and for introducing us to the OSU Marine and Geology Repository. We have some time for viewer questions now. And we'll start with a few we received during registration. Guests, please continue to add your questions as well. First question is, what is the oldest core you have archived in terms of both when it was acquired and the age of the sediment?
So that's a great question. The oldest core in terms of the sediments within it is 25 million years old, and I believe that's from kind of the middle of the Pacific Ocean. And then in terms of oldest collected, it'd be from February 1962, one of the Antarctic cores collected on the Burton Island as a part of the Deep Freeze project.
Cool, that's amazing. Another question is, are there microbes living in the soil? And if so, do they die when the core is taken out of the water?
Yeah, there are microbiology studies in marine sediments is really a big field. So yes, they're living in there. There are some of them that have been in sedimentary records going back tens of millions of years that they found alive. And these things live even though they're barely fed in some sort of stasis thing. So that when we bring them up, they're probably still there and alive, but then they get mixed with other microbes that come around. So it's kind of hard to do research unless you take a lot of precautions on microbiology. So the microbes are still there, or other ones are forming. Maybe those die, maybe they get eaten by other ones. It's hard to know, but yeah, there are definitely microbes running around.
Here's a good follow-up question to that. What are the floaty things in the core collection videos?
Okay, and the first one, those are flocks, which are combinations of organic material and marine sediments. So that was in Petermann Fjord, and there's a glacier in that coming into that fjord, and there's a lot of sediment coming in. So it's very turbulent water, and there's a lot of material floating around in there. And then later in the other one, there's these things called pyrosomes, which are just, I believe, noticed for the first time on the Oregon margin in 2017. So those are new found features that were very prevalent in that year.
Interesting. Do you have any idea why?
I think it's because things are getting a bit warmer. So it seems like it's a bit of maybe a global warming phenomena of getting new, more tropical organisms making their way up to us.
Wow. Okay, now I have a three-part question. Why do cores need to be refrigerated? What is the temperature of the refrigerator? And why are they kept at the temperatures that they are?
All right, so conditions in the cold room, which you see behind me, we keep that at about 36 or 37 degrees Fahrenheit, which is basically selected because it sort of replicates conditions at the bottom of the ocean. But it's also an important temperature range in terms of preserving the sediments, because we want to keep them moist as long as we possibly can. So we want to prevent them from drying out, prevent and inhibit the growth of mold and that sort of thing. But we also don't want to go on the other end of the spectrum and make them too cold, because if they freeze, they may kind of ruin some of their physical properties.
Awesome. Somebody is asking if the public can view the repository.
Yes, I think they can, but you need to contact the curators first to set up a time to do it. So, and we have events and things like that to bring them on. So that's, you know, we've probably been talking about setting up more public events for those kind of things.
Yeah, open houses would be the most fun, I would think.
Yeah, I mean, the first one we had that I referenced in early 2020, I mean, we had a huge attendance. It was amazing to see so many people interested.
Yeah, we'll have
And
to.
I know we were looking forward to many more of those events, so hopefully they're coming soon.
Yeah, exactly. Just get through COVID and we'll be there.
Okay, have all the cores been cataloged, or are there some that haven't been analyzed yet?
Well, cataloged and analyzing is two different things. So we have notes and records on everything, and we've undertaken a huge digitization project to make everything barcoded, scannable, so we know what's all there. And Val can tell you a lot more about that. But collecting data on them, no, there are many cores that have never really been analyzed, and there's much more that can be done. So we usually wait for scientists to tell us what they want to do with the cores, and we provide samples to them. But there's a ton more information and analysis that can be done. We just mostly have them.
Yeah, like Joe said, a lot of these expeditions, when they go out, they have very specific research objectives. And usually, you know, you do want to get an interdisciplinary group together to study a lot of different things, but there are lots of other ideas that may come down the line, new analytical techniques. So that's why we're here, is to keep everything, and then the sediments can get revisited.
Cool. That reminds me of another question I saw here, which was maybe related. Tell us about your partnership with OSU Vet Med.
Okay, well, we use the veterinary school. We use their CT scanner primarily is what we do, and they've made that available to us if we can get in early in the morning before the animals come in to CT scan sediment cores, which has been an amazing technology. Gives us incredible images and allows you to see things that you could never see with, you know, visual inspection. It allows you to look inside the cores without actually getting in on them. So it's a completely transformative technology, and we love their allowing us to measure our cores in their facility. It's been fantastic.
That's great. So going back to moving the cores from Florida, what was the most, from Florida State University, what was the most surprising hurdle to overcome when you were transferring the collection?
Yeah, so I was down there in the summer of 2018, as well as Maisie, our chief curator, and a team of folks that we hired in Tallahassee to assist us. But yeah, it was an intense 5 weeks, and I can tell you that definitely the physical, like the literal bottleneck, was a long hallway to the front door, because that facility never had a loading dock. So everything came in through the front door. So everything, in order to bring it out, we had to kind of shove it all on a cart down the hallway, and then assemble things outside and dodge Florida thunderstorms.
That feels like a real behind the scenes sort of thing. People don't appreciate when they just see those beautiful rows behind you.
Yeah, it was amazing. I wasn't sure it was going to be possible when we first went down there to do the recon on the move. I mean, it was a facility that got packed in over 50 years collecting material and was never designed to be unpacked. It was It was a long way from the road. It was a long way from the door. That was, it was an amazing job they did bringing that stuff over. It was incredible.
How many trucks did it take to bring the collection?
There's 14 52-foot semis. We packed one basically every 2 or 3 days.
Wow. It's a huge undertaking.
Yes.
Okay, a few more questions. What is the longest sample that can be in the refrigerator? Does it last forever?
Well, that's a good question, because we cut things into essentially 5 foot or 1.5 meter long sections to hold them, and we call them sections. And at Florida State, they had sections that were previously 3 meters long. So to move them, we had them cut to 1.5 meters long, which makes it easy. Now they fit in our D tubes, they fit in our racks, and we have them. And now we can measure them on tracks, which we couldn't do when they were 3 meter long sections. So that worked out really well. But you could have a long core that had a bunch of these 1.5 meter sections. So I've heard of piston cores that have been collected that were more than 60 meters long. And through the ocean drilling program, they can drill down and collect cores hundreds of meters. So it's possible, using a variety of technologies, to really sample very deep into the seafloor.
And then I guess in terms of like the curatorial side of things, if you want to maintain things in the cold room, we do want to keep them moist as long as possible. And Joe was talking about the older cores when the standard was 3 meter long sections. Those are pretty dry now because curation standards change over time. So D-tubes weren't a thing in the 60s as they are now, which preserves cores much longer. I've sampled cores from 2000 that are still in pretty great shape. But those dry cores are still totally valuable, and there are plenty of analyses that you can still do. You can still take samples from them. You can take pictures of them because cameras were different then as they are now. So they're still totally valuable research-wise. They may not be as moist, and at some point they may get decommissioned and put into dry storage. But yeah, as long as they haven't crumbled to dust, they're still usable.
So I think a good follow-up question to that is on the topic of preservation, what is the sealing protection on the core in storage after you split them?
The sealing. Sealing. So like, how do you seal them up? Is that correct? Is that what we're?
Yeah, sealing or protection on the cores. How do you?
Yeah, definitely. So yeah, they're a pipe and then they're cut in half. So there's the face of the core, and we preserve that, keep it kind of intact by covering it with plastic wrap. So kind of super nice plastic film. A little bit more heavy duty than what you may get for wrapping up your sandwich. And then we wrap that and put that inside the D-tube and tape that up, and it's good to go. Kind of has its own little environment there.
And then another question related to that one is, why do cores change color when they are split?
They oxidize. So they're down under the seafloor in their own environment. There's not much oxygen. And when they get up and they get split, oxygen gets hold of them and it starts causing chemical reactions. And that oxidation, you'll see often black streaks and other things that will just disappear eventually with oxidation. So we can try to preserve things in anoxic environments if needed. It's harder, but it can be done. And to, just try to get those ephemeral properties that are of these, sediments when you bring them up from the seafloor.
Okay, somebody wants to know about future adventures. What future areas and locations of study are planned?
That's a good question. We've been doing a lot of work off the margin here. We're going to keep doing that because we're finding out that there are really fantastic records on the Cascadia margin off of Oregon and off of Washington we're learning a lot, and there's a lot more to learn, and we're finding out that those records are really rich in the information we can obtain from them about climate variations, about earthquakes in the past, about deglacial processes and glacial lakes, like some of the videos we showed that showed Missoula floods. We're finding out that the marine records might be much more complete than what you can get from terrestrial records. So you can really begin to understand how that took place, how Missoula floods took place, whether there were multiple lakes contributing, how that happened, and the impact it had on the Pacific, and whether that then impacted climate. So we're sort of looking at this in much more nuanced and detailed ways, and there's a lot that can be done there. I myself also have some projects off of Greenland, and I kind of like working around there to try to understand how that ice sheet has evolved through time. It's a pretty fascinating thing, and we don't really know that much about it, except for the fact that with things warming up, it's likely going to be melting a lot more in the future. So we should understand how that process is taking place.
Trying to decide which direction to go from here. There's so many good questions related to what you just said. Well, let's make it a little more personal for a minute. And Joe, wanted to ask you specifically, of all the places you've traveled to collect samples, where would you like to return, and which experiences stand out in your mind as the most exciting of your career?
Well, the Arctic is just amazing. I find the Arctic to be just beautiful and fantastic. And it's nice when you're cruising around there and you're close to land and you can see the mountains and you can see the Greenland ice sheet or Ellesmere Island. It's really just an incredible environment and a unique experience. And I feel lucky to have been able to go up there. I've spent some time in the Southern Ocean, which was less fun because we spent a lot of time running from storms where you have 50-foot seas and things that could, sink your boat if you were in the wrong place at the wrong time. So it's rough and harder. So I like the Arctic more than the Antarctic myself personally, but
Yeah,
I haven't been to Antarctica yet. So always that.
And Val, I understand you have not yet been on a research cruise. Would you like to? And if so, where would you want to go?
Yeah, I definitely do. I think it would be so exciting to be a part of that. I would definitely want to go somewhere around Antarctica, given that I manage the Antarctic core collection. I get to hear, all these great stories of what happened down there, and also see the science that's produced. And while being here, and that's also a very exciting part of the story, I think it would be a great experience to get down there and be a shipboard curator at some point.
Yeah, well, I hope you get that opportunity.
Yeah, it might be rough seas, but maybe that's the best place to go for your first time. Just get it over with.
Sounds good. You may have already sort of answered this, but I'll ask it more specifically. One of the audience questions was, what did the course tell us about ice ages? And when was the last one, and how often do they occur?
Well, that's a very good and, sort of nuanced question. So the last one was about 20,000 years ago that we were in a full ice age, and it takes time to fully retreat. So the process started from the end of the last interglacial. So about 120,000 years ago, it was as warmer than present. And then it started getting cooler and cooler and cooler. And eventually at about 20,000 years ago, it was into a full ice age, or 25,000 years ago. And then from about that time to about 11 or 10,000 years ago, ice was retreating. So it's really a dynamic thing that happens. That's an oscillating process. If it wasn't for present global warming, we'd be going into an ice age right now. There is what they've called a neoglacial, and a few thousand years ago, ice was advancing. We were seeing that when we were up in Peterman, and looking at what they call neoglacial ice that is now receding again. Naturally, it wouldn't be receding, but it is because of human caused changes to our atmosphere. Long answer.
So, sorry, did you want to say something else?
No, I just said long answer.
Oh,
There's a lot you could say about that question.
yeah. And then bringing it a little more local, what was Oregon like during the last ice age?
Yeah, I don't know. I wasn't here, but no. There was ice up at the Cascades. There wasn't ice around here except for during Missoula floods. You had Glacial Lake Alice, which actually flooded the Willamette Valley. So there were episodic floods that were coming in. I imagine it was drier. There were big lakes in the east, and then sea level during the last ice age was about 400 feet lower than it is present. So, you know, your beaches would have been much farther out, and you would have had a broad shelf that was exposed. And the oceans would have been dumping right off the edge there. So it would have been the coast would have been a vastly different experience and place to see. It would be, yeah, it would have been amazing to see it.
Okay, so have fossils or other records of animal or plant life been found? I'm assuming in your samples. Which areas of the world and which historical time frames?
Well, those cores are just chock full of fossils. They're often marine organisms, plankton of different kinds and benthic organisms, and they leave their shells behind. So we find lots of what they call microfossils in the cores all over the place. Occasionally, you know, you could find the remains of whales or things in there if you cored the wrong spot. There's some bones and things occasionally come back, but that's very rare. Mostly it's the microfossils that we find in our cores because we're pretty far off the margin.
Yeah, but it's really cool. So the bottom of the Androl core that I talked to you guys about, there's, you know, tropical plant debris and things like that from 13 million years ago. So that's really neat to kind of think of like these places that we currently think of. The coldest cold, it must have been cold there for a very long time, but it's really neat to kind of think about in the past. Well, actually, it was quite the opposite.
Yeah, that is really interesting. I think we have time for one last question, and I think I'll ask both of you this. What do you love most about your work at OSU?
Okay, if I start, I just think it's fantastic to find new information and new things about the world. And these sediments really they're sort of like the solutions manual to Earth. And they tell you about everything the Earth is possible that could have happened in it and has happened in it in the past. And it's just amazing. So I love doing that. And I love telling people about it. It's really fun to educate people about all the cool things we find.
Yeah, I mean, it's such a fun thing. I remember when I first started working with sediment cores years ago before I worked here, it was just, you think of it, well, it's all just mud, right? But no, it's like, it's very different depositional settings, and you just get to learn about all these cool events and stories of the world. So I think they're just kind of really exceptional to work with, and I like it a lot. And yeah, working here is just a lot of fun. I like OSU. I like CEOs. I think the community and culture is a lot of fun, and yeah, it's been great. I like it here.
That's great. Okay, I do have to ask one more question about the facility, since it's you have the new collections, and it's just been finished. How do you see the future? This is my question, so I'm going to stumble through. But what do you think this facility is going to do for us in the future? I mean, you guys are thinking way out, the next 50 years. Like, what is it going to bring to OSU and to the world?
Well, I think it's a great research facility, and what we're just trying to do is add knowledge to this collection. So having the collection, and then now we're sort of installing a series of instrumentation that we can have around the cores, so we can just bring data and understanding into our tangible representation of what the seafloor is, that's really almost impossible to assess otherwise. And we can provide this data on it and help us really go much further. And I mean, I think, well, it's hard to imagine. I mean, there's many things that we can do with the repository in the future that I think could really change our understanding of the past. And I think there's lots of opportunities for education. I think there's lots of opportunities for research. Yeah, you could go on. So kind of come up with a long answer on that one.
Yeah, and I think it's important to note that, you know, these kinds of facilities, you know, they need to be more than just a place where the cores are organized and stored, to facilitate that future research, going back to some of those questions that we answered. So yeah, the instrumentation, that piece is key.
And the people. Got to have the people. That's always the key. They're the ones that make it all happen.
Thanks, Joe.
You guys have it.
You're welcome, Val.
Well, thank you both so much for being with us today. I learned so much, and I'm sure our audience did too. And thank you, audience, for your participation and your curiosity and thought-provoking questions. I highly recommend visiting the Marine and Geology Repository website, where they have a lot of interesting resources, including more videos and even some interactive guides. I think that's going to be posted in the chat if it isn't already. And yes, once again, thank you to Val and Joe. A couple final items before we end today. Our next Knowledge Break webcast will be we will be hosting two faculty from OSU's Carleton College of Veterinary Medicine to learn more about treating cancer in dogs and cats. It takes place on Wednesday, July 14th at 4 p.m. You can register for this talk, view past recordings, including this one, and check out many more great resources by visiting the Beaver Lodge, the digital hub of the OSU Alumni Association at osualum.com. We'll also be sending you the registration link. Thank you again for joining us today, and thank you, Val and Joe. We hope to see you all again soon, and have a wonderful afternoon.